Okay, so welcome to the Master of the Skies Weather Briefing Show, where we talk all things weather. And so in this edition of the show, we're going to be talking about a omega block pattern actually situated over Europe right now. And if we do that, we could take a look at the windy site here, where we're taking a look at jet stream level at 250 millibars or 250 hectopascals, but you can see the upper level wind flow. That's basically going from the eastern Atlantic here and going upward and over a lot of Western Europe and then into Scandinavia, and then digging down into the Mediterranean over into Greece. And if we superimpose the geopotential height pattern, you could really see how this upper level flow pattern is really carving out sort of the Greek letter omega, and that's why we call it an omega block pattern. It's actually a block pattern that really tends to stay put over several days, where you have persistent clear skies and usually dry and hot weather over the ridge portion, and rather humid, cool and rainy weather under the upper level lows on each side of this ridge. So that would be concerning a lot of the eastern Mediterranean and Greece area, as well as the eastern Atlantic, North Atlantic, and over towards Spain and Portugal. And so this is an omega block pattern. It's kind of coincidental that part of it is actually affecting Greece, especially this upper level low here. You could also see further west into the Atlantic a ridge, and then a trough over the western Atlantic and eastern U.S. seaboard. This low is actually a remnant of the Hurricane Idalia that actually sort of dissipated over the subtropical Atlantic here, and then got sucked up into this sort of upper level trough, and is extratropical now and just spinning its way over just to the southeast of Nova Scotia. But if we concentrate again here over Europe, you could see this upper level ridge with this omega block pattern. And what we could do here is actually, instead of looking at the geopotential height field at 250 millibars, we could take a look at the surface pressure field. And if we do that, you can see that the surface high pressure is located really under the strong subsidence portion of this upper level ridge, usually located halfway between the ridge axis and the trough axis. And you can see with a 1025 hectopascal high, with flow in the northern hemisphere around high pressure clockwise. And so actually this high pressure at the surface is actually feeding into this upper level ridge, as is the upper level low that's actually feeding in this warm air into the ridge. So it's sort of a self-maintaining mechanism in these instances, where hot air is continually fed into this ridge, and that tends to strengthen it, and usually also it makes it rather long-lived. And so that's what we're experiencing actually right now. What we could also take a look at with this ridge is actually the freezing altitude, and actually it's been extremely high lately over Central Europe. As a matter of fact, we're up to about 5,200 meters, which is really, really high. With the previous heat wave at the end of August, we actually beat a record where the freezing level reached 5,250 some odd meters. And now we're about 5,200, so we basically have almost the second highest value. And just to give you an idea of how high that is, the highest peak over Western Europe, the Mont Blanc, culminates at 4,800 meters. So this is actually 400 meters even higher than that. So extremely hot air here aloft. That is also translating into some pretty hot temperatures at the surface. But of course, now, since we're in the beginning of September, it's a little harder to actually heat up the land surfaces as intensely as during the summer. So we're basically breaking records, especially aloft in the mountain locations, more so than really at the surface. So that's relating to the upper level ridge. And now if we take a look at what's going on with these upper level lows on each side, where we're having this humid and rainy weather. It's really becoming quite intense here over parts of Greece, where they've had over 24 hours of extensive rain over the same areas that is really creating some pretty hectic, record-breaking rainfall and really hazardous conditions in terms of some flash flooding that's been going on in that region as well. You can really see this dynamic cutoff flow with a lot of jet energy feeding into it with diffluent flow loft, and that's really helping the upper level lift in terms of deep precipitation systems. And given the temperature of the Mediterranean also, you're also feeding some tropical moisture with some thunderstorm activity that's also embedded in a lot of this heavy rain. So as a matter of fact, if we could take a look at some of the flooding that's been going on in parts of Greece, you can see it's really quite intensive. A lot of the streets experiencing a lot of flash flooding and really quite problematic and even life-threatening, where some intense warnings are in place in that area regarding this heavy rain. There's also been some waterspout activity. You can see this waterspout that was actually taken as a picture here over the Aegean Sea and the coast of eastern Greece. And you could see quite a set of waterspout. Typically, when you have upper level lows, you have quite a bit of cold air loft, and over the warm Mediterranean, that usually sets up a quite unstable environment, and that usually tends to favor waterspout formation, especially at the end of the summer and early autumn here in this region. I think there's also actually a video of it. If you could take a look at that really quickly, and how it actually, this is accelerated, but you could see how the waterspout basically came on shore and then sort of lost its circulation as it hit land. So there you go. Now, if we go back to the windy site, what we could do now is actually take a look at some of the radar activity in terms of the precipitation echoes, and we can actually zoom in here. You could see, if I put this into motion in terms of the animation, some of the heavy rain basically concerning a lot of the eastern Greece along the Aegean Sea here. You can see a lot of this rain is also accompanied with some thunderstorm activity. And so since it's concerning basically the same areas over and over again with some training of echoes, that's usually a recipe for quite a bit of heavy rain and dangerous flooding conditions, with flash flooding also occurring with some of these convective cells embedded in this precipitation system. And as it stands, this upper level low will basically just keep spinning here for a few more days while drifting a little bit further to the south as the days go on. Another thing I wanted to show you maybe is some of the satellite-derived 12-hour precipitation totals that have been estimated here over the area over the day here on September 5th. And you can see a lot of the values surpass even 100 millimeters in 12 hours. Some regions even reached up to 500 meters in 12 hours, with some of the orography amplifying the lift along this coastline here over the western Aegean Sea. I think we even had a reading on some of the orography here of 700 millimeters of rain in 12 hours. So these are really close to record-breaking values in terms of rain, and it's no surprise that it's basically responsible for some flash flooding as we've seen over these last 24 hours. Now, if we go back to the radar, you could see that if I zoom out a little bit, you can see this upper level low is just spinning. And there's also another upper level low over Spain and Portugal that's kind of filling a little bit more. And so they had also quite a bit of rain over the last few days, and also had some flooding problems in parts of Spain. But that's sort of dying down a little bit. But this region over the Mediterranean will remain active while slowly drifting to the south, this upper level low will be doing. Actually, if we go back to the satellite imagery, you could see also how the clouds are associated with this upper level low. If I put that into motion, you could also see all this cloud material feeding northward ahead of this upper level low. And as it turns out, if we take a look at the pivotal weather map from the GFS model, you could actually see a really high values of precipitable water on the order of 1.5 to 2 inches of precipitable water values, and those are pretty high values, spinning up and advecting all that Mediterranean moisture northward into Greece and responsible for all this heavy rain. You can see that as time goes on, this upper level low will tend to migrate a little further to the south by Tuesday of next week, and so progressively Greece should be less affected starting over the next few days here, but still pretty critical. And so at least over the next few days, and we'll just have to keep an eye on it. Now, if we go back to the windy site and zoom out a little bit, you can see here we're nighttime here over Western Europe, but you can pick out the cloud systems thanks to the moonshine. You can see over Greece, and also this vast upper level low over the Eastern Atlantic, also feeding this humid and rainy weather over the Iberian Peninsula. And of course, the clear skies located over the upper level ridge, as you would expect, over much of France, Switzerland, Germany, and also southern Scandinavia, which is also cloud free. Now, just to maybe finish this show here, let me just go back to the upper level flow here at, let me go back up to 200 hectopascals and look at the geopotential height. Now, if we go forward in time over the next few days, you could see that this upper level low just basically stays in place, but tends to fill in to some extent. But it still stays quite trophy in nature. And if I go back maybe and to the initial time and then take a look at the surface pressure pattern, you can see this upper level low here, and you can see how over time it tends to sort of drift to the south into Libya over the next few days. What we'll have to take a look at more closely, though, is also the sea surface temperatures, because they're quite warm in this area. Now, if we take a look at some readings here, you can see that we have about 27 degrees Celsius in terms of the sea surface temperature of the Eastern Mediterranean, and that's why this upper level low, as it starts to fill, should bear watching to see if there's no maybe a sort of a transition from a cold core to a warm core system, to see if we may actually form sort of a hybrid tropical system or sort of a metacane. We'll have to keep an eye on that, but it seems that the upper level trophiness and the upper level shears should impede this system from becoming too tropical in nature, but we'll certainly keep an eye on it. Okay, so there you go. That's the Master of the Skies weather briefing show for today, and until next time, I'll catch you next time. Bye-bye.